Welcome to the deep dive. Today we're diving into something pretty universal, stress. We often think of it, just as a feeling, right? A mental thing.
Right.
But the science, well, it paints a very different picture.
Hmm?
Our sources show it's way more than that. It's actually a physical force impacting, well, pretty much everything in your body.
It's absolutely right. And our mission today, really, is to get past just the feeling of stress and look at the hard science. We're digging into how stress, and we mean any stimulus, internal or external, that triggers a biological response, how it hits your major physiological systems.
Okay.
We're focusing on the really crucial biological findings for you.
And the big takeaway, right off the bat, is kind of jarring. It means we really need to shift how we think about stress. It's not just an annoyance. The research makes it clear. Stress can trigger or worsen a huge range of diseases. Things from, small imbalances right up to life-threatening conditions.
Exactly. And the common thread connecting all these diverse effects across the whole body, it's hormonal. Yeah, it really stems from activating the HPA axis. That's the hypothalamic pituitary adrenal axis. That leads to the release of stress hormones, mainly glucocorticosteroids. Cortisol is the big one.
Right, cortisol.
And these powerful hormones, they mediate responses everywhere. To really get it, we need to start where it all begins. The central nervous system.
Okay, let's unpack that. So for a long time, since maybe 1968, the idea was stress caused functional changes in the brain, like temporary shifts in how it works.
That was the prevailing hypothesis, yes.
But the studies we looked at show something, well, much more serious. What about the actual structural, physical damage? That was surprising.
Yeah, the structural damage is perhaps the most worrying part. We're not just talking feeling a bit foggy or drained. Chronic stress, especially if it's severe or goes on for a long time, it physically damages brain tissue.
Damages it how?
It can actually lead to atrophy of the brain mass, a measurable decrease in its weight.
Wow, actual shrinkage.
Physical shrinkage, yes. And naturally, these structural changes then ripple outwards, affecting things like cognition and, significantly, memory.
Okay, memory. Let's see, focus there. There's one part of the brain, the hippocampus, critical for memory formation, right? It seems especially vulnerable. Why does it take such a hit from stress?
It boils down to receptor density. The hippocampus just happens to have the highest concentration of those glucocorticosteroid receptors we talked about.
Okay.
So it's the most responsive area to those stress hormones floating around. When cortisol levels stay high for too long, the damage there is pretty profound.
What kind of damage specifically?
Well, researchers see fewer dendritic branches, fewer neurons overall. They also see structural changes right at the synaptic terminals where neurons connect. And crucially, a big drop in neurogenesis.
Neurogenesis, the birth of new neurons.
Exactly. Fewer new brain cells being created in the hippocampus tissue itself.
That sounds like a recipe for, well, long-term problems. Is there clinical evidence connecting high cortisol to this hippocampal atrophy and memory loss?
Oh, definitely. And it comes from a few different angles. You can look at people with Cushing's syndrome. That's a condition with constant high glucocorticosteroid levels.
Right.
Or people taking high doses of synthetic anti-inflammatory drugs, which act like cortisol. Both groups show hippocampal atrophy and related memory problems.
Okay.
And maybe even more striking, you look at MRI scans of PTSD patients, you consistently see smaller hippocampus volume, and that often correlates with things like weaker verbal memory.
So there's a clear link.
A very clear inverse relationship. High plasma cortisol from prolonged stress leads to memory reduction. And importantly, if you can lower that cortisol, memory function tends to improve.
Okay, but here's a twist, because stress doesn't always seem to wreck memory, does it?
No, it doesn't.
Our sources pointed out that under certain conditions, like short-term, maybe unfamiliar, unpredictable situations, or even life-threatening ones, stress can actually improve function temporarily. Sharpen memory, even. That feels like a contradiction.
It seems like one, but it's really about timing. It's a temporal thing. The key finding is this. Stress hormones, the glucocorticoids, are actually crucial for strengthening memory consolidation.
Strengthening it.
Yes, but only if they're present shortly after the learning happens. They help lock it in.
Ah.
However, if you experience stress before you need to retrieve a memory, like right before a test,
Then it causes problems.
then it significantly decreases your retrieval power. So the timing of the stress relative to learning or recall is absolutely critical. It dictates whether stress helps or hinders.
So it's not just if stress is present, but when it hits in relation to trying to store or recall something.
Precisely. And if you widen the lens to just general cognition learning, making decisions, judgment, you see a similar kind of pattern.
How so?
Mild stress, the kind that might get you motivated, that can actually help cognitive function, especially verbal memory. But once it crosses a certain threshold for that individual, that's when you start seeing problems with judgment and memory, affecting both the hippocampus and the prefrontal cortex.
Okay, so the brain is literally changing shape, shrinking even under chronic stress. But these powerful stress hormones, the glucocorticosteroids, they don't just stay in the brain, do they?
Not at all. They're circulating everywhere.
And they're simultaneously signaling a major shutdown in our body's defense system, the immune system.
That's a perfect transition because that link between, emotions or stress and getting sick, that idea is ancient.
Yeah, I saw mentions going back to 200 AC,
Right.
melancholic women and
Right.
cancer risk.
Exactly. And those studies in the 1920s linking stress to suppressed immunity, like higher TB risk, they were definitely onto something.
So what's the modern understanding? How does stress actually suppress immunity?
Well, those stress mediators, we keep mentioning CRH, ACTH, and especially the glucocorticosteroids, they are potent immune suppressants.
How do they suppress it?
Glucocorticoids, like cortisol, directly inhibit key immune cells. Think lymphocytes, macrophages. They also reduce the production of cytokines.
The immune system's messengers.
Right, and in cases of really severe long-term stress, researchers have linked the lower activity of specific cells, cytotoxic T lymphocytes and natural killer cells, directly to things like genetic instability and even tumor growth. Stress basically hits the mute button on the immune system.
Leaving us more vulnerable.
Much more vulnerable, yes.
Okay, so while the immune system is winding down, another system, the cardiovascular system, is kind of ramping up chaotically. The link between stress and heart disease, CDD, that seems really solid now.
Unequivocally verified, yes.
Yeah.
The positive association is very clear.
How does that hormonal cascade hit the heart and blood vessels?
The main player here is the autonomic nervous system, the ANS. Stress hits, the ANS activates immediately, and this sets up a really dangerous conflict between its two branches.
Let's start with the one most people know, the sympathetic system, fight or flight.
Exactly, that kicks in, and you get increased heart rate, stronger heart contractions, blood vessels constricting generally, and higher levels of lipids, fats in the blood.
Okay.
Now, if that sympathetic overdrive stays on long term, that directly contributes to plaque buildup, atherosclerosis. It contributes to arrhythmias, irregular heartbeats, and ultimately it significantly raises the risk of a heart attack, a myocardial infarction.
So that's like slamming the gas pedal down. But you said there's a conflict. What about the parasympathetic side, the rest and digest system? Isn't that supposed to be the brake?
It is, but under severe psychological stress, stimulation via the limbic system can trigger a paradoxical parasympathetic response that causes a sudden, sharp drop in function.
A drop. So the opposite.
Exactly.
Yeah.
Physiological whiplash, you
Yeah.
can see the heart rate decrease dramatically, contractility go down, blood pressure plummet. In really extreme cases, the heart might even stop momentarily.
Wow. So it's getting conflicting signals speed up and slow down at the same time.
Precisely. That kind of rapid, contradictory signaling puts immense strain on the whole cardiovascular system.
And clinically, the sources mention something called alpha adrenergic stimulation from psychological stress. That increases heart rate and oxygen demand.
Yes, and that's particularly dangerous because it also enhances coronary vasoconstriction, tightening the arteries supplying the heart itself.
So if you already have some artery disease,
It dramatically increases the risk of a myocardial infarction. It's a dangerous cycle.
you also mentioned modifiers, though, things that change this picture.
Two important ones. First, individuals vary a lot in how their autonomic systems respond to the exact same stressor. What sends one person's heart rate soaring might barely affect another.
Okay, individual differences.
And second, gender plays a role. Estrogen seems to offer some protection. That's likely why, on average, women tend to develop heart disease about 10 years later than men.
That's fascinating. A clear endocrine link there.
A very clear one.
And speaking of other systems, let's talk about the gut. The whole brain-gut axis or brain-bowel axis. Stress seems to really wreak havoc there.
Oh, it absolutely does. It hits the gastrointestinal tract in two main ways. First, appetite. That's a two-way street. Stress affects appetite, and your diet affects your stress response.
Okay, appetite. What's the second way?
Normal GI function. Stress messes with absorption, how permeable the gut lining is, even acid secretion.
And this is where it can stir up existing conditions, right, like inflammatory diseases?
Precisely. Stress makes the GI system more prone to inflammation. It can reactivate inflammatory conditions that were quiet, like colitis. And it's very strongly linked to IBS, irritable bowel syndrome. Mental state hugely impacts IBS symptoms.
And CRH, that main stress hormone regulator, is involved here too.
Yes, corticotropin-releasing hormone is thought to be a key player in controlling gut motility changes under stress.
And there's that really weird detail about gut movement. It sends opposite signals.
Yeah, it's like biological panic in the digestive system.
Hmm.
Stress does very specific contradictory things. It actually slows down or prevents the stomach from emptying.
Giving you that full bloated feeling.
Exactly. But at the same time, it speeds up movement in the colon.
Which leads to, well, the urgent need to go.
Right, so it's jamming the brakes in the stomach while flooring the accelerator in the colon. Total chaos.
So we've got the brain shrinking, the immune system suppressed, the heart in conflict, the gut getting opposite signals. The source is really emphasized. This all loops back to the broader endocrine system.
That's the essential takeaway. You really can't separate stress from overall endocrine function. Even minor stress fires up the HPA axis, and that activation influences the thyroid, the gonads, the pancreas. They're all interconnected and regulated together. Stress is truly a whole body event.
Okay, so stepping back, the science confirms this kind of duality of stress, doesn't it? It's vital for short-term survival, keeping things in balance.
Absolutely necessary for homeostasis and survival.
But when it's prolonged or too intense, it causes widespread damage, these pathological conditions across basically every system we've touched on.
Exactly, and that leads directly to the treatment implications. Because stress hits so many areas, effective treatment has to be just as comprehensive.
Yeah.
Meaning it often requires both medication, pharmacological support, and non-pharmacological approaches. Things like specific lifestyle changes, exercise, better nutrition, maybe structured stress reduction techniques, a multi-pronged approach.
And that brings us back, as we wrap up this deep dive, to maybe the most critical point from the research. How we respond to stress is incredibly individual.
Highly individualized, yes. What helps one person manage the effects on their brain or heart or gut might not be the right approach for someone else at all.
Right.
And what I find really compelling is that the very same stressor, a looming deadline, a difficult conversation, a traumatic event, can trigger vastly different physiological responses in different people.
Different brain changes, different heart reactions.
Yeah. Exactly. Different cognitive impacts, different immune responses, which leads to, I think, a really important question for you, the listener, to think about.
Yeah.
Given everything we've discussed today, this deep, personalized physical impact of stress, the actual brain atrophy, the immune suppression, the chaos in the cardiovascular system, how fundamentally do we need to rethink our standard, often one-size-fits-all approaches to managing stress? How can we better address our unique individual biological vulnerabilities?
It's a powerful question to leave things on.
Yeah.
Rethinking stress management from the biology up. Thank you for joining us for this deep dive into the total body impact of stress.